So I'm going to catch up to you guys. Now this I'm going to make times and flip what I'm doing. Is that cool?
Yes.
So that I'm going to put here. Now the one last thing, is that cool so far? Is that jive with what you guys got? Yes?
So again, the W plus 6 is squared. Just 1 squared.
You totally can do that. Sure. Yeah. And the one last thing I have to factor is this dude.
Difference of two.
Will you guys allow me to do this? So I don't have to rewrite everything.
Yeah.
Is that cool? So all 4 parts have been completely factored. Now you can just go to town, kill some shit, right? What shit dies? Oh, what's up? Which one? Oh, this guy. All right. I totally agree that this part here is something cubed. Is this part something cubed? No. So the minute that anything is not cubed, it can't all be a cubes. Right? Cubes has to have everything can be cut into 3 pieces. I can't cut W into 3 pieces nicely. Right? But W cubed I could, but in this part I can't, so it's not that. And another thing that saves you from that kind of mistake is you have to train yourself to always look for GCF first. Because sometimes that's the only damn thing that happens. So you're sitting there trying to make everything else work, and if you just would have done GCF, you would have been done with that piece, right? So what dies here?
That W5.
Yeah, the W5, W plus 5 is gone.
W6.
Yeah, this W6, sure.
And then another W6.
Another W plus 6. And one last thing. You have a couple W's. You have one W. So one W cancels. So now you collect the survivors. Don't leave anybody behind. Right? Freaky ass little algebraic zombie expressions. You don't want them to. So who survived on the top? Just the W survived on the top, right? And who survived on the bottom? W minus 6. Does anybody feel like nice that all that shit becomes this? Yes, all right, good. It's kind of satisfying for some of us. Oh, that shit is just this. Some of us are like, oh, that shit is just this? I'm like, why do you say it like that? We just did awesome shit. There's all this shit, we made it this. That's awesome. And you're like, I don't know if you know what that word means, Jeff. What's up? Go ahead, come on. All right.
So it's just 4 problems in one?
Yeah. And then, so once you do those 4 problems, now it's just all about kill whoever's the same on the top and the bottom. I like it.
Yeah, on the top, W squared plus 11W plus 30, isn't it supposed to become W plus 5W, or W, like, plus and minus on both of them?
No, because two reasons. Well, one reason. They have to add to be positive, right? So they have to be the same sign, because they multiply to be positive, so they have to be the same sign. And they add to be positive, so they're both positive. The only way it can be positive and negative is if this number is negative. Because what's a positive times a negative and negative?
And then you just pick and choose.
And then you get the numbers that work correctly, right? I didn't use 3 and 10 because they don't make 11. I used 5 and 6 because they make 30 and 11. I like it. Yes? So this W plus 6 killed this one. And they're both gone. And then this W plus 6 killed this one. Is that cool? So another little mistake that can happen is I'll see something like somebody will factor and I'll get somewhere like this. And does everybody see that's after they factored, they got here? And then they'll do this. You know, holy shit. This thing is dead. The minute you cross these two through, it's dead. How did this one die? What's left to kill it? Nobody. Its clone ain't there to kill it. This is the clone to kill each other. He's the third clone hiding around the corner. But you can, the minute you cancel something, it's gone. It can't do double duty. It's not that strong. Right, guys? All right. It's a weird little mistake, but I see that. Yes?
So I see that, I know why we flipped it, and that's why we changed it to multiplication. But why did we flip it? Like, why did we change it to multiplication?
You saw that whole thing yesterday, right? Where I try to show why that's true?
No, yeah, I know, but
Okay.
you say it again.
Let's see. So, quickly, if I had 2/3 divided by 5/7, that's 2/3 divided by 5/7. That bottom sucks. I'm allowed to do the same thing to the top and bottom, multiply or divide. So I'm going to multiply the bottom by something to make it the best bottom I could possibly make it, which is 1. So I'm going to multiply by 7/5, because that makes it 1. Got to do the same thing up here. That means that equals that. Period.
Oh, okay.
That's why we divide, we multiply by the reciprocal. Kick ass. What about all the x's in there? I don't care. There's still fraction divided by fraction. It works the same way. Okay. All right. So that kind of catches us up to where we left off. 7-1, 7-2, basically the same idea. 7-2 is just more stuff in a problem, right? Same idea though. Factor, kill. Just be careful about division. So here's where we've made it to. Section 7.3 should hopefully be relatively easy, because how do you make fraction, addition, subtraction easy? You start with the denominators the same, right? So 7.3 is all about, hey, the denominators are the same. You're like, please, yes. So for example, 7.3. If I had something like,
That was super easy, wasn't
That'd be
see, I love that reaction. Yes, it is.
That'd be smart.
That one is. They will get a little bit harder, but the only way to make fractions hard is to make the bottoms different. That's the suck-ass part, especially when you got x's running all over the damn place. So I do have a very cool way that some of you guys have probably seen before. Some of you guys maybe have never seen it, as to how to find LCD really easy for numbers or letters. See if you agree with me on that word. So what do?
Just combine them.
Just combine them. I'll put this top together with that top over their common bottom. Now, one big mistake I get right here is somebody will say squared. I don't see any over 2x minus 1 squares. Here, real quick, let me say something about fractions. What kind of terms are you able to add or subtract? They have to be what kind of terms? Like. So I can only add and subtract like terms. I've got 3/4 minus 1/4 is 2/4. Notice how the bottom doesn't change, of course, because that's what I'm keeping track of. It's the same way as 3x minus 1x is 2x, the exact same way. So finding an LCD is making them like terms. That's what it is. So of course the bottom doesn't change, because that's what I'm keeping track of how many of those. I got 4x of these minus 2 of these, so I got 4x minus 2 of these. If you put 2x minus 1 squared, I'm like, where the shit did you get that from? I don't see any 2x minus 1 squared shit anywhere, right? Is that? All right, just want to quash that right now, hopefully. Now I'm not done. The last step in any fraction problem is to check to see if it reduces. So how do I do that in this case? Sort of, not really, no. Factor, yes.
Factor the
Yes.
top.
What comes out of the top?
2.
2.
2x
Two
plus
right.
1. Or minus.
And then, of course, what cancels?
The answer is 2.
Yeah, the answer is 2.
Alright, yeah.
Stay with me now. That kicks so much ass. Holy shit. So really the only way they can make this section as hard as they can is to just make this some, difficult factoring problem, right? Does that make sense? So let me take one right out of the homework, and then we'll take a break. I think you guys need a break. They really don't. Let's see if they have one like that. No. Oh, let me show you this. Here we go. That doesn't really matter, Jeff. I'll take the same one. Let's see.
It's all one term, or 2x. So the whole term,
All right, now here is the other way that this could be easy to make a mistake. What things make us make mistakes? Fractions, negatives, zero, right? Those things kind of find a way to make mistakes. There's a minus in the middle here, right? So there's a couple different ways to take care of this. If you wrote this down, this is wrong. If you wrote this. That is wrong. That is wrong. And some of you guys are like, that's what you just told us to do earlier, Jeff. This is why I hate math. You math people. This is not the same as what we just did at all. This isn't. How many terms were on the top of the problem I just did earlier? 1. So that's easy to do. How do you subtract 4? I subtract 4 is what I do. How do I subtract both of these? Subtract 2x is minus 2x. Subtract negative 5 is plus 5. Yeah. This has got 2 parts to it. I got to keep track of both parts. Nothing changes. The minute you think we're doing something completely different than what we used to do, you have to come see me because you're wrong. You're not looking at it correctly. And this is how you lose faith in the whole process. You're like, well, it depends on what the hell day it is. On Tuesday we do this, and on Thursday we do this. No, that's impossible. That is impossible. I couldn't keep track of all this shit. We're like, let's change all this every other day. No. I really want this to make sense. So watch. What's 7 minus 5? 2. So 7 minus anything that is 5 should be 2, right? So no, what? You got like, no, watch. So if I took 7 and I took, isn't 8 minus 3, isn't that 5? Isn't that 5? 8 minus 3, is that 5? Yes. So I take 7 minus that, the answer should be 2. But if I write it like this, 7 minus 8 minus 3, what's the answer I get from that? Oh, shit. You guys see how that's a problem? 8 minus 3 is 5. When I take it away from 7, I'm supposed to get frickin' 2. Of course I am. So what did I do wrong? I didn't take 5 away. I took part of 5 away. I only subtracted the 8. I didn't subtract the other piece of 5. Right? You guys? 8 and 3, if you subtract them, they are 2 parts of 5. Together they make 5. The way I wrote it first, I only subtracted the 8. I didn't subtract the whole 5. I really want this space. So if I write this like this, I didn't subtract this whole thing. I just subtracted this. But that's not what that says to do. One way to take care of this, there's no perfect way, is to make this, do you remember how you make this plus and negative?
Yeah, plus.
Like that? And to be really honest, the really perfect way to do this, which would be a little bit clumsy, so let me show you my thought process on this. Another way to make sure that students do this is to remind you guys that if you had to do 4 divided by 9 minus 2, and you put into your calculator 4 divided by 9 minus 2, why is that wrong? If you put that in your calculator, are you going to get the answer to this? What do you have to put? So anytime you have a big-ass division bar, what is hidden, what we humans don't need, but what algebra and calculators need, is the fact that this is actually in parentheses. So this is in parentheses, this is in parentheses. So if there's a minus here, it really is minus distributed. Because there's an understood parentheses there. They're so understood, we've forgotten completely that they're freaking there. We got a big-ass division bar. What do we need that for? Well, you got to remember it's there, or else you're going to do stuff wrong. All right, so let's do this one correctly then. That sounds like a good idea. So it'd be x minus 9 minus 2x
I didn't do it yet, but I know.
plus 5. Is that cool? Do you guys see what I'm saying though? Please, dear God. I understand that's why a lot of you guys have lost faith in math and you're like, I never had it. Yes, you did. You just lost it, trust me. Is because you feel like, now we're totally, everything's different now. What the shit? No, the minute you feel like that, you have to come see me because you're not looking at it correctly. Yes?
So if there's a big ass division bar, that it's always a parentheses, like the one on the bottom of the parentheses.
Totally, yes. So this is also understood to be in parentheses. Here it doesn't really need it, but it is in parentheses. I like it. Yes, ma'am. You good? Bukan is like, you call me ma'am. I'm not going to ask. All right. So what's the next step?
Violate one.
Yeah. So then I get
Negative 1x
good,
minus 4.
good. And then what's the last step now? I've done all the simplification I could do. Now I got to see if it good. See if it reduces. What can you factor? You can actually factor the top, but we'll look at that in a minute. How do you factor the bottom?
X plus 4, X minus 1.
Good. The bigger one positive to make it positive in the middle. Do you see what I mean by, can't you factor the top too? Don't you see something that wants to be the same?
Negative 1.
If you took a negative 1 out, you'd of course get positive, positive. And now you can see what cancels. Is that cool?
Yeah, but you can't ever have a negative in the front though, right?
Of course you can.
Oh, really?
Totally.
Oh, okay. I thought you'd have to factor it, like write it like that with the negative 1 out front, x plus 4.
Yeah, totally. I mean, yeah, this is how I can write this.
But you can't write it the other way though, right? If that, like, say that you couldn't factor this problem anymore and it was just that answer, you couldn't write the answer as negative x minus 4, right? Could you?
So like, I'm not sure what you're asking.
Maybe if it couldn't be factored.
If it couldn't be factored anymore, so say the bottom is...
Oh, say the bottom couldn't be factored.
Yeah, and then...
Then it doesn't matter which way you write the top because these are
okay.
both the same.
Okay.
Does that make sense?
Yeah, I just thought that you couldn't write it that way. Like
You totally
couldn't
could.
Write an x
Totally could.
Negative, okay.
Yeah, yeah.
So if it was negative 4 minus X, you could reverse it into your other.
Totally. I love it. In fact, even if I just took a negative 1 out and I got a 4 plus x, well, that's the same thing as x plus 4. So they'll kill each other.
How did you get to negative x minus 4?
Oh, x minus 2x. Negative 9 plus 5. Just like terms, yeah. Once I get the bottoms the same and put the tops all over it, now it's just cleanup. Now it's just put your like terms together, right? And here, the last step, of course, die. So you're negative 1 over x minus 1. All right. So why don't we... Any questions on that one?
Is there any situation where you can over-parentheses something?
Oh, hell yes. Basically, anything that can go wrong, some student will find a way to do it, is what I've found. That's why it takes me a while to grade some tests because there's so many creative mistakes. I got to figure out how much do I count that off for. It's not like... So as a teacher, it's weird. You're like, I'll take this many points off for this kind of mistake and this many, and then somebody's like, you've never seen this kind of mistake. Shit.
Gotta give the points for creativity.
Yeah. Sometimes, maybe. Not really. Yes.
So if I make the one and like calculate some plus and then 2 is the equations and then
No. 7-2, there's no equations. 7-1 would be like related to this problem, right? Reduce this. 7-2 would be related to this problem, right? Reduce that, do that problem. So that's what I meant by 7-2 is just like 2 7-1 problems side by side. Do you guys get that? So 7-2 is just like 7-1 on steroids. It's like the next level. Equations are going to come in 7-6, I think.
so every time we have this kind of problem, do you have to use, the first step, the first step where you like distribute the negative sign?
Yes.
You have to do that every single,
Anytime there's a minus in the middle,
just do that
you have to distribute it to all the terms up top.
every time.
Now that very first problem, there's a minus in the middle, why did we not worry about this? Because there's only one term up top. Didn't we just write -4 for that first problem, or whatever? I think it was -4. You guys kind of with it? I didn't have another term to have to be careful about. There was just one term. But the minute there's more than one term, I got to be careful, make sure everybody gets that minus. Nobody can escape being subtracted because this problem says them subtracting all this shit. Yes?
And why wouldn't the minus be distributed to the bottom?
Because there's only one minus. There's not a negative for the top and a negative for the bottom, right? Good question, but that's the only reason. Once I take it through the top, there is no other one for the bottom to have.
Gotcha.
If there were negative over negative, it would have been a plus in the middle, which would have been fantastic, right? Do you guys understand that? So there's only one negative. It can go to the top or the bottom. The top makes more sense here because if I put it on the bottom, they wouldn't be the same anymore. Oh, shit.
The problem is to solve, like, figure out the top, not the bottom.
Yeah, for this kind of problem, since the bottoms are the same already, you're focusing totally on what's going on at the top. The next section after this, 7.4, is going to be where the bottoms are not the same. And we'll have to figure out how to get LCDs. Yes?
I have a question. Did you take out a -1?
Totally.
Okay. And you left the X there, and then.
Yeah, if I take a -1 out, both of these signs change.
Okay.
And the reason I did that is because I saw then it would cancel with this guy. That's the only reason. If this was x plus 5 and x minus 1, I wouldn't have done that, which sort of goes along with your. I wouldn't have done that. If you did, you're not wrong.
Okay.
But I'm like, why would I do that? Nothing's going to die. I think that might have been more like what
Yeah,
you're asking. Yeah.
exactly,
But if you
yeah.
did it, I'm not going to take points off. It's just like showing me you checked. I'm like, that's cool with me.
Where'd the -1 come from? Off the negative of the X?
You can do that with anything.
Oh, yeah. It's sort of like asking me, if I say factor this and you do this, I'm like, where did the 2 come from? Well, it came from both of these guys. Didn't they both have a
okay.
-1?
Right.
So I can take that -1 out?
Sure.
That's all.
Okay.
Good. Let's take a break. Let me catch it before. What time is it? 5, 10, 15. You want to come back? Like 9:30? You want a decent sized break? 9:30?
Sir, can you bring
And then I can run and get some better markers.
Can you bring that
Yeah, the synthetic division. Okay. I'll get that too.